There is something moving through our solar system right now that was not born here. It came from somewhere beyond our sun, somewhere around another star. It crossed the enormous darkness between stellar systems, entered our neighborhood, passed around the sun, and is now heading back into deep space. Astronomers call it 3-Eye Atlas. And when the James Webb Space Telescope finally got a detailed look at what this visitor was made of, scientists found something they weren't expecting. Not evidence of aliens. Not an artificial spacecraft. Something much more scientifically interesting. Its chemistry suggests that this object was formed in an environment very different from our own solar system. And the deeper scientists looked, the stranger the story became. Imagine taking a piece of ice from another planetary system, throwing it across interstellar space for billions of years, and then somehow getting a telescope powerful enough to analyze what is trapped inside it. That is essentially what astronomers have been given. 3-Eye Atlas was discovered on July 1, 2025, by the NASA-funded Atlas Survey Telescope in Chile. Its trajectory showed something extraordinary. This wasn't an ordinary comet orbiting the sun. It was moving on a path that indicated it came from outside our solar system. That made it only the third confirmed interstellar object ever discovered passing through our planetary neighborhood. And suddenly this wasn't just another comet, it was a sample of another star system. The problem was that 3-Eye Atlas would not stay. It was passing through. So astronomers had a limited window to learn as much as possible before the object disappeared back into interstellar darkness. And that's where the James Webb Space Telescope entered the story. Webb didn't simply take a photograph of 3-Eye Atlas. It analyzed the light coming from the comet and separated that light into a chemical fingerprint. This is one of the extraordinary things about astronomy. Scientists cannot travel to most objects they study. They can't collect a piece of a distant comet and bring it back to Earth. Instead, they study light. Different molecules absorb and emit light at characteristic wavelengths. By analyzing those patterns, astronomers can determine what gases are surrounding an object, even when that object is hundreds of millions of kilometers away. And Webb found something remarkable. For the first time in an interstellar visitor, it directly detected methane gas. But the methane itself wasn't the biggest surprise. The amount of methane relative to water was unusually high compared with familiar comets in our own solar system. And there was another clue. 3-Eye Atlas was releasing an unusually large amount of carbon dioxide compared with water. That combination immediately raised a bigger question. Why is this comet chemically so different? To understand why this matters, think about our solar system as a kind of chemical neighborhood. The planets and comets formed from material that existed around the young sun. That doesn't mean every comet is identical, far from it. But they share broad chemical characteristics because they formed from related material within the same planetary system. 3-Eye Atlas didn't. It formed somewhere else. So when scientists find chemistry that looks substantially different from our local cosmic neighborhood, they're effectively looking at evidence of a completely different planetary environment. And this is where the story gets even more fascinating. Webb detected unusual ratios involving carbon and deuterium, a heavier form of hydrogen. Those isotope ratios don't resemble those commonly measured in comets from our solar system. Researchers use these chemical fingerprints to work backward, asking what kind of environment could have produced an object like this? The answer points toward a formation environment very different from the one that produced our own comets. NASA researchers reported that the data are consistent with 3-Eye Atlas having been ejected from its original planetary system billions of years ago. Think about what that means. The object may have spent an enormous amount of time wandering through interstellar space before we ever saw it. And the chemistry locked inside its ice survived long enough to tell us something about the place where it was born. But there's an even more interesting detail. The methane Webb detected appears to have been buried beneath the comet's outer surface. Methane is highly volatile. It can easily change from solid ice into gas. So why was it still there? One possibility is that the material was protected beneath the surface until the comet passed close enough to the sun for heat to penetrate deeper into its icy body. As 3-Eye Atlas warmed, previously hidden material began escaping into space. In other words, the sun may have effectively opened a chemical archive that had been sealed for an enormous amount of time, and Webb was there to read it. This is why 3I Atlas is so important. It isn't merely an unusual comet, it is an opportunity to compare two different planetary systems. Our own solar system is the only planetary system from which we have studied comets up close. Until now, our understanding of how comets form has largely been based on objects that were born around our sun. 3I Atlas gives scientists something completely different, a visitor carrying evidence from somewhere else. It allows researchers to ask whether the chemical ingredients that shaped our solar system are common across the galaxy, or whether our cosmic neighborhood is unusual. And that question reaches far beyond one comet, because every planetary system begins with chemistry. Ice, dust, gas, carbon, water, organic molecules. Over time, those ingredients can become planets, moons, atmospheres, and potentially the environments where life can emerge. 3I Atlas gives us a rare glimpse into how some of those ingredients were assembled around another star. And there is one final twist. The discovery does not mean scientists have solved the mystery of where 3I Atlas came from. They haven't. Its exact stellar birthplace remains uncertain. We know it came from outside our solar system. We know its chemistry differs substantially from typical solar system comets. We know its isotope measurements point toward a different formation environment. And we know it has probably been traveling through interstellar space for an extraordinarily long time. But there is still much we don't know. And that uncertainty is exactly what makes this object so valuable. Because for perhaps the first time, humanity is not merely looking outward at another star system. We are watching a piece of one pass through ours. 3I Atlas will eventually leave. The gases around it will fade. Its coma will become harder to see. And eventually this visitor from another star will disappear into the darkness from which it came. But the information it carried will remain. Every molecule detected by Webb becomes another clue. Every unusual isotope ratio becomes another piece of the puzzle. And every difference between 3I Atlas and our own comets tells us something about how differently planetary systems can form. For most of human history, the stars were unreachable. We could only look at them. Now, something from another stellar system has come to us, and for a brief moment in cosmic history, humanity has a chance to ask a question that was once impossible. What does another solar system look like when it leaves something behind? 3I Atlas may be only one comet, but it could become something much more important. Our first real chemical clue to a planetary system we may never be able to visit.